Hi guys, so I'm Ali from Hack Science, and I'm just going to set the scene a bit for disrupting the lab, as well as tell you guys a bit about what we're doing at Hack Science. So we all know that scientific research changes the world, from breakthrough technologies to life-saving medicines. But research is slow and it's becoming increasingly more and more expensive. So at Hack Science, we accelerate research by automating manual lab processes, and we do this by using IoT and web technologies. And this is our team. There's 5 of us right now, and we're growing, and most of us went to Imperial. And we bring together deep expertise in hardware, software, product, and science. I myself am a PhD student, and I previously founded a hardware startup. I'm here tonight. Ignacio's here, and also Henry, so come talk to one of us. So as an example of a researcher, we're going to talk about one of our friends at Imperial. This is Dr. Michael Delves, and he's a fantastic malaria researcher. Some of you guys might actually know him. And he's got great ideas about stuff to research, but unfortunately Michael has a problem that stops him in his tracks. And that is that he has to spend 3 hours a day while his malaria cultures are growing, manually replenishing the growth media. So that looks like this. He will take each flask out of the incubator, suck out the old media by hand, and replace it by hand similarly. And Michael's actually not alone. We've spoken to researchers at some of the top institutions in the world, including UCL, KCL, Imperial, even Stanford in the States. And what we found is that 62% of researchers are spending more than half their time in the lab doing things by hand, which is a crazy amount of time. Now that stat alone should tell you guys that the lab needs disrupting. So you think there must be a better way. Well, in Michael's case, there is another option, but it costs £250,000. So this is like an automated cell cultivating machine. And this is a trend we see across not just automated tools in science today, but generally scientific equipment. It's super expensive. Often it takes up a lot of space, and it's just not that easy to use. I mean, you guys have probably all used the piece of science equipment connected to the Windows 98 computer, so I don't need to talk about that too much. But there are new options appearing. So this is a new option that could be available to Michael. He could outsource some of his research to a cloud lab. So for those of you that don't know, a cloud lab is essentially a laboratory in a warehouse somewhere in the world, and you send them your protocols, they run it for you, and they send you back the data. This is pretty interesting. But there are also other options appearing now, and that's thanks to the maker movement. So the maker movement is essentially a movement of people making things for themselves, one-off things or things in small quantities. And the reason that's become viable and possible is because it's super easy to create software-controlled electronics now. Sensors have become super cheap because of mobile phones, and you can print things of any shape quickly and easily using a 3D printer. And this has actually led to cheaper versions of scientific equipment starting to be made. This is leading to a citizen science revolution where we're seeing people who couldn't traditionally afford to have scientific equipment buy equipment and run their own experiments outside of a lab environment. This is actually a super early prototype of what Bethan will be speaking about later, just an example. But at Hack Science, we're interested to see whether we could use that same maker technology to automate some of those manual lab processes I mentioned. So to test this idea out, earlier in the year, we brought together scientists and engineers at Imperial, and we ran the world's first lab automation hackathon. And it went a bit like this. So first, the researchers, we had an ideation session where the researchers pitched their manual lab processes and formed teams with engineers. Next, we trained everybody in Arduino, 3D printing, laser cutting. And finally, we had the 2-day hackathon, which is essentially 2 days of intense building going from the initial idea to working prototypes. But at the end of those 2 days, we were blown away because people had proved that affordable automation was possible. And they proved it across 9 different areas of research: solar, malaria, cancer, just to name 3 of them. And just to give an example of some of those tools, so here are some of the tools that were created. I'm going to dive in on 3 of those just to give you an example of what's possible. So one team created a wireless cell density sensor. You drop this in your flask of cells, and essentially it wirelessly takes optical density measurements, or OD600 measurements, and that lets you know how many cells you have per unit volume. It's pretty cool. One team built a Coulter counter, so that lets you count cells passing a particular point in a microfluidic channel. Typically, these cost hundreds of thousands of pounds. These guys built it for 400, which is pretty great. And finally, someone automated column chromatography. So if there are any chemists out there, this is super laborious normally. These guys automated it just with some cheap optical sensors and some clever mechanical parts, which is very cool. And you remember Michael? Well, we're actually working with Michael to automate his process. So this is an early prototype of our cell cultivating tool. It's not going to cost £250,000. It's going to be very cheap. And yeah, we've actually progressed past that now and created something that can clip straight onto these flasks that people cultivate in. So that's pretty cool. And yeah, if you guys are interested in that, so I'm sure there's some of you in the crowd who grow cells. If you're interested in this, just take a photo of this link, sign up. And if you use the referral code SD for Science Disrupt, we can add you guys to the top of the list for like user testing. We're just like testing out the tool right now. So an interesting thing we've seen in the software world is open source. This has allowed software projects to basically have massive distributed teams across the world working on a project 24 hours a day, 7 days a week, and combining all their ideas. And we want to use some of those same forces in science. So we're planning on open sourcing all of our own tools and also all the tools from the hackathon. And we have a vision for our platform to kind of have millions of open tools. We want the sharing of designs for open tools to replace the sharing of methods between scientists. And that's going to make reproducibility just so easy. So that's our kind of vision. And obviously, researchers deserve the credit for the work they do, so we're working on making it super easy to cite and keep track of citations. And the final thing we noticed from the hackathon and we're working on is that people could build automated tools, but when it came to building that next level of software to allow you to control and monitor your tool remotely, that's where people really struggled, and that's much more the realm of a software engineer. But we wanted to make that easier too. So we've created the Hack Science Hub. Essentially, you plug your new tool into one of these 4 USB ports, and you can create a cloud-based interface for your tool using a drag-and-drop interface. It's kind of like LabVIEW in the cloud, but easier, and you don't need to know anything about how the internet works, which is pretty cool. So yeah, that's coming mid-2017, and again, if any of you guys are makers and want to try that out, we're really happy to get involved. We've actually used it to build an interface for our own cell culturing tool. This took us about an hour to put together, but I think it's already better than a lot of the interfaces we see for scientific tools today. So yeah, that's a little bit about what we do at Hack Science. And if you guys are interested in knowing about our next hackathon or learning about any automated tools that might come out, if you go to this link, bit.ly/hsmail, you can sign up and we'll let you know about those things. And yeah, just get in touch. We love hearing from you guys. We love chatting to researchers about what you guys do, anyone who wants anything automated, anyone who's making stuff, and yeah, just come talk to us.